3 years. And the idea really is just to kind of do a Q&A session. This is something that's been asked from our customers time and time again. And this is actually our first session, so we're actually trialing this. Do a Q&A, which is basically answering questions and trying to come up with the best answers we can for our clients mostly, and people who are interested in Inspire. So this is more of an interactive session that we can have with our engineer. And we're going to be basically covering the Inspire product, obviously mostly related to the design workflows. So I'm just going to share a quick presentation just to get started. So you'll see here that I have a slideshow. I just want to make sure everyone can see my screen before I continue. Ash, does it look visible?
Yeah, you can see.
Wonderful. Okay, so we're going to do introductions first. My name's Benoit Gervais. I'm with Futurescape. I've been at Futurescape for 12 years now. We are actually a vendor for Altair and Ansys products. On Altair side, predominantly the HyperWorks and the Inspire line, also as well as S-Frame. My background is mostly in design, product development, in aerospace defense, and also application engineering and sales. I'm just going to hand it over to Ali, who's also going to be presenting. Ali, do you mind doing a quick introduction of yourself?
Yeah, definitely. Thank you, Ben. So hi guys, this is Ali from Futurescape. So I'm a lead application engineer with Futurescape. I've worked on multiple projects in the past, wherein I have led the team from the very design to the manufacturing of the parts. Herein, I take care of the customers in regards to the application side of things. So we sell different products, as you might understand. From Altair, we have HyperWorks, Inspire, we have SimSolid. So I take care of the workflows. If any of the customers need help with the workflows, I take care of that. And I also assist with different things, even if they have some design problems that they are facing through, we definitely assist them for that as well. Right. Over to you, Ben.
Thanks, Ali. So continuing on, the agenda we're going to be doing is just a quick PowerPoint demonstrating just the overview of the product. Ali is going to be doing a quick workflow presentation showing the basic workflow of Inspire. And then at the end, we're going to open it up for questions, which will be the most exciting part of this webinar. And we're going to want to hear the feedback from you guys and ask you what you'd like to ask us and see what sort of questions you'd like us to answer. So we'll get started. What we're going to be doing today is Ali's going to be doing a quick presentation. This is an aircraft door support, and we're going to be showing the workflow to actually using this support, which is actually a true case study for an aircraft, and is an example we actually use from time to time. And this is basically the main part. We're going to be showing the whole workflow from start to finish using this part. What are we going to be showing? First of all, we're going to be showing actually how to modify and simplify geometry inside Inspire. So inside Inspire, there's actually a full CAD geometry creation workflow, also simplification, in order to be able to do simple modifications on your parts that you're trying to optimize. The next part we're going to be demonstrating is topology optimization. So actually showing the optimization workflow. For those of you who are new to this technology, the idea is that we're using algorithms to actually come up with intelligent designs using engineering inputs in order to be able to reduce the weight of the parts and actually make them higher performing. The idea is that the computer actually can come up with more intelligent ideas for shapes as opposed to human beings. So it's a really great starting point for doing concept design. After that, we're going to be moving on to how to set up the interpret the topology results. So a lot of times we get asked, you know, when we're getting topology results, how do we implement that into the design workflow? How do we actually review and look at the different optimization shapes and understand which one is the best one? Because oftentimes when you're doing optimization, you're trying to come up with different ideas, and usually Inspire will give you more than one result. And then lastly, what's really important is Altair has a very powerful tool set of different types of manufacturing simulation capabilities. So we'll actually show you how to use Inspire to actually do design for manufacturing. So which basically makes sure that you can go in and not just come up with a shape that can't be manufactured, but actually utilize that shape and optimize it for specific manufacturing workflows. Moving on, that's basically what we're going to be doing. We're going to be doing the Q&A session. So I'm going to hand it over to Ali now, let him present, and then after that, we'll kick it off into the questions. Over to you, Ali.
Thank you very much, Ben. So I'll just quickly go ahead and share my screen. Please let me know when you're able to see the screen.
Yeah, we can see it.
Wonderful. Thank you very much for confirmation, Ben. Hi, everyone. Thank you very much for joining today. So as Ben mentioned, we'll be taking those questions and molding those questions into a workflow where we'll be seeing and answering those questions along the software and see how things work out, right? So the very first question that we had was to simplify the geometry, right? If you're doing any simulation, if I'm doing any simulation, the very difficult part will be to simplify the geometry initially, right? If you have an initial design, you need to go back to the CAD team and ask them to simplify the design for you. And that might take a lot of time to go back and forth, right? So Inspire, within the Inspire, you have few tools wherein you can play around with the geometry, right? So here I have the geometry tool on the top, as you can see. We have various operations that you have in your traditional CAD interface, and you can use these operations to just simplify your model, right? So herein, as Ben mentioned, that this is a part of an aeroplane, and we need to simulate this and even see for the optimization. And the initial part will be to just simplify the geometry. And the reason why we simplify the geometry for optimization is that so that we have a full packaging space wherein the software can, go around and play around with numbers and show us what will be the optimal shape. As you might see initially, it's made for subtractive kind of manufacturing and wherein milling operation is used and drilling operation is used, right? Now let me go ahead and do some simplification, right? I just go in here. We have something called a tool simplify. I just click on it and we have multiple options to simplify, right? Do I have an imprint that I want to remove? All there are rounds, holes, or I just want to plug the holes up. In my case, currently I'm just looking to fill up these holes. So I just click on holes, software will go around the geometry and find all the holes that it can fill. Let's say I do not want to fill those holes. I just remove these holes and I want to manually select. I just select these holes, click OK, and it will go ahead and fill those holes for me. So that easy it is to just go in and simplify the geometry for you. Right. Again, there are some more simplifications which we require over here. So I just click in here, it will become flat. Let's say I want flat over here as well. The software is quite smart in terms of it can identify what I'm looking for. Right now, it's a square block, a cuboid. So herein, I can just play around, and the software can play around to give me an optimized shape. Right now, once we have the simplification, we can go ahead and set up our solve for optimization. Right. So if in that case, I just need to change the toolbar from geometry. I'll come to the structural toolbar that you see over here. So here we have the structure tool. You just come in here and have multiple ways to have different kind of boundary conditions in here. But before I move on to the optimization, there's something called, if you're optimizing a part, the software might also optimize the areas or the regions where we have the boundary condition. What I mean by that is, let's say I have a support in here. I have a cylindrical support at the bottom. But if the software go ahead and simplify, it might remove material from one side and not remove from another side, right? So I need to let the software know that these are the regions wherein please don't remove any material. Again, in that case, I need not to go back to my CAD team. I have some within simplification, we have something called partition. Again, it will find all the areas wherein I can make the partition. Let's say I do not want these. I just want few of these. I just select those cylinders. And at the back side as well, just go in here and select these. And click the play button. It will show me what's the thickness that I require. Let's say 3 mm is good. I just click check mark and it will divide these components from the main component. So I can see in the structure tree, the division did happen, right? Now I can just let the software know. So see, this is my design space. You're only bound to play around with the material only in these regions. Please don't do anything for these regions because these are the where my boundary conditions are. Now we are good to start with our setup of the model. Initially, I'll have some supports. Let's say I have some supports at the bottom. I just insert these supports on the 4 holes in here. And I can just move out of the tool. Right. This is the one load case. Let's say I want to have one other load case and generate another load case and also copy these supports in that very load case. Right. Now we need to insert some kind of forces. Let's say I just want to have a force over here. Just let's say 1000 Newton, or let's say 2000 Newton for now, and click OK. This was for the load case 3rd. Let's say for load case 2 also, I'll require something in the Z direction. Let me make it 4000. Enter. Now this is the basic setup with which we are good to proceed with the optimization, right? Now within the optimization framework, we have multiple constraints that we can apply, right? So for example, we can apply something called displacement constraints, in which an edge or a surface can be mentioned that this surface shouldn't displace by this much amount. We can give a boundation for that. Right. Let's say as of now, I'm not requiring for that. I require that the part should be symmetrical in nature. So I have those kind of constraints in here. I just select the symmetry. Again, now in symmetry, we have different kind of symmetry. We want simple symmetry or cyclic symmetry or cyclic symmetry, right? Cyclic or cyclic symmetry. Now let's say I just want symmetry. I just select the body and I can just remove the planes which I do not want the symmetry about. So once I'm good, now I can move to the next step. As you might see, the workflow here is quite simple. We are moving from left to right, using the things which are required and using the tools that suffice our need, and we're good to move on to the next slide. Now comes different kind of optimization for manufacturing, right? So we have something called shape controls. So we have shape controls for different kind of manufacturing process. So depending upon what I'm looking for, I can optimize the solve accordingly. Let's say the manufacturing process that I'm using is using single draw. I can have that kind of a process and optimization for that. If you are doing split draw, radial extrusion, overhang means something which we are 3D printing, or if you are using milling kind of operation for manufacturing. So depending upon what we are intending to have as a manufacturing process, I can select in here and the software will make sure that the design that will be getting out is able to get manufactured by that very process. I will just apply single draw and I just select the draw direction. And once I'm good, I can just move on. right? Now coming on to running the optimization. So I just click on optimization in here. And we have different kind of things to play around here as well. First of all, I can name the solve. Now, what's the objective? So we can have different objective depending upon which the software can have the optimization. So basically there are three. One is to maximize the stiffness. Second is to maximize the frequency. And the third one is to minimize the mass. Depending upon what option we select from here, we'll have different kind of breakdown in the below tables. For example, if I just want to maximize the stiffness, I need to set the mass target that I have in my mind for the output design space or output model that I'm looking at. Again, if you want to maximize the frequency, you can have that kind of support as well. Again, you can have both the load cases or just one load case as well. And in case of, let's say you are looking to minimize the mass, that case you can just give a minimum safety factor. Let's say 5 is the safety factor that I'm looking for. Below this, it shouldn't go. Right. So depending upon what's my need or requirement in terms of manufacturability, in terms of objective, I can apply before the solve and we are good to go. For the initial solve, let me select, maximize stiffness. So if I just click in here, let's say 30 is good. Now, again, I can have some kind of a frequency constraints if I want to. Even the thickness can be varied, right? So if I want a minimum thickness to a certain point, although the software will automatically calculate based on the model, although if I just want to input anything, I'm really allowed to do so. For this session, we are running just a faster simulation. And let's select both the load cases for now. Now, once we are good, you can just click on run. And just a second, one of the load case, we haven't entered the force. Let me move it to 2. And we are good to run now. Right. Now the optimization is going around and it will see what are the load paths, right? Where is the path wherein the load is carried, and it will try to have mass in those very sites and remove the mass from the region where it isn't any load path. Now we'll be open for a few questions right now because it will take some time to solve. If you have any questions, please feel free to ask at this point in time.
Does anybody have any questions they'd like to contribute? Ash, you're the moderator, I believe.
Yes, ma'am.
Yeah, any questions have been submitted by the client so far?
George, we will definitely send a PowerPoint.
Oh yeah, okay. We see right here and here. Yeah, we have the. Can you send me the certificate? George, do you mind elaborating? What do you mean by certificate? Do you mean like a training certificate? And then the second one, the PowerPoint. Yes, we will be sending the PowerPoint. Yes. Okay, moving on. We'll just wait for Ollie to finish.
You can unmute yourself if you have any questions. Feel free to unmute yourself. Yeah. We will also send the recording of this session for your future references as well. Yeah. So we have one question from Jensen. My company uses Inventor and has no appetite to bring in another CAD platform. Is generative design component of Inspire available as a standalone? Jensen, the Inspire interface that you see, the CAD interface is with the Inspire itself. It's a complementary feature that you get with Inspire, right? It's not that it will replace your CAD tool. It will help you if you are taking some geometry out of Inventor, right? And if you want to just quickly go ahead and make certain changes, you can do it inside the software itself. You need not to go back and forth again and again, right? It won't replace your CAD software. It's just a complementary feature that Inspire has so that you are easily able to manipulate your geometry within Inspire. Once you make some changes in the geometry in the Inspire, you are free to save that geometry as well. Let's say you made the changes and you want to send it across to your design team for making the same changes in their CAD as well. So you can save the geometry as you can see in here. You can transmit the CAD file using a Parasolid, SGP, whichever way you want. Right? Does that answer your question, Jensen?
Yeah, I think maybe some of the users are muted, so I think that's fine, Ali. I think that answers the question.
I got it. I got it.
Yeah, yeah.
So let me take you to the model that I've already solved for you, right?
Ali, we have another question. We have another question.
Yeah, the question is, when setting a minimum thickness, if an unforeseen load is newly placed halfway along the part, such as this hinge arm example, how best to reanalyze or foresee acceptable deformation from a load?
Just a second, I'm checking the question.
Yeah. So I think what he's asking, Ali, is let's say you did an analysis on what part, and then you needed to reapply another load on that hinge that was not predicted. Would you be able to reanalyze or re-optimize that after you've gotten the result?
Yeah, so once you enter certain condition, the design will be created based on those conditions, right? Let's say for this, I've just applied symmetric loading. I haven't applied any kind of manufacturing constraints, and this is the part that I have. Now, I just want to go back and play around with certain things. I freely can do so, right? So I can just come back to the design. Now I can make the changes. Let's say you want to change the loading condition. You want to change the thickness. You're freely allowed to do it from here. So you have multiple design studies that are going around side by side, right? So you have all the studies that you can compare side by side and see what kind of results you are getting, right? So it's not that once you have selected, you are moved away forward, now you cannot move backward. That's not the case. I've analyzed this component, just one component, I've just gone back, made certain changes in the load cases, and again have reanalyzed. Right. Hope that answers your question. So moving on, if you have any questions, please feel free to shoot out in the Q&A session, and we'll take it up from there. So we performed the analysis. I did it just sometime before this event. So I've done few of the results so that we can talk about the results, right? So I've just applied the symmetric kind of loading, no manufacturing constraint in that case. This is the kind of geometry that we get out. I can see how it has optimized. I can see the areas wherein there is no, no load path. It has removed the material. Even in here, we have option to play around slightly, right? Let's say I want a bit thicker. I can move the slider, which we have over here, to decrease or increase the thickness. Can go it down. So I can just slide it over here. And now in here as well, we have multiple options, right? So we can analyze how this part is behaving with our new set of condition, new set of geometry. I need not to go again back and sorry, do the boundary conditions and all. I just click on analyze. It will take this geometry and go for the solve. That's it, right? I need not to do repetitive tasks. It will keep on running. I can just close it and I can
Okay.
play around with others.
Hi, this is Rob. Just a question there then. So with what you've just done there, you've chosen this configuration of the topology. And if you want to see what the actual stresses and displacements and everything are for that, that's what you just did with there with clicking analyze. Is that correct?
Totally correct. Totally correct.
Okay.
That's what I
All
did.
right. That's a lot more convenient than it is doing it in HyperMesh.
Yeah. If you have access to HyperMesh, most probably you'll have
Yeah.
access to Inspire.
Yeah, I have it. Yeah. I've been doing this type of thing with HyperMesh for years, but I haven't really explored Inspire that much.
I got it. So Rob, Inspire, all the results that you have in Inspire can be taken to HyperWorks, right? As you might see over here, you have limited control over the variable that we have. In HyperMesh, you have a lot more control. That's why it is way more complex as well. So what you can inculcate in your workflow for the initial phase of the design, you can just use Inspire and see how things work out. Once you have a good model, you can take the same file. So if you just open this run folder for you, so you can see you get all the files that you can, move to HyperMesh directly, right? You have FEM file, you have H3D file. So inside the Inspire, under the hood, it's the OptiStruct that is running. It's the same solver that you use with your HyperMesh or HyperWorks. So you can use these results, even this CAD model, take it to HyperMesh, play around a bit more and get much more accurate results over there. Right. I guess that answers your question. Now,
yeah, thank you.
You're welcome. So the run that we just performed is completed now. We have the displacements for vertical loading as well as for lateral loading. We have displacement, factor of safety, and all those kind of things over here. Right. Even once we have the results, I'll just show you. For example, let's move to 3D print. Right. As of now, there is no solve for it. Let's go to optimize, and I'll analyze for this as well. So this geometry that we have got out, this is for 3D print kind of a optimization. You might see traditional way wouldn't be able to manufacture this part like this. So we can run an optimization for this kind of solid as well. Once we run the optimization, we can again have the analysis for that. And even compare side by side with with different optimized results to see wherein we are having maximum effect of safety, minimum mass, and all those kind of things. So you can intuitively check all things in just one window. Once it will be done, I'll show you that as well. I've also run one for extrusion. So as you might understand, for the extrusion, this is something that we'll be looking at. And when it will be extruded, and this kind of a geometry that the software has come up with. So the software knows, basically depending upon the kind of analysis that you're running, what kind of optimization will be suit the manufacturing process. And based on that, it will try to optimize for that very condition. Right. Now it's running. In the meantime, if you have any questions, please feel free to ask. So in terms of, if I just show you what are the different conditions that you get. So for example, if you have a single draw or split draw, you can just select the plane. If you have, let's say, extrusion, again, you need to select the plane through which the extrusion is going to take place. Now, if you are 3D printing, therein you can give an angle, right, for overhang. So above that angle, the overhang shouldn't be there. And in case of milling, is something called excess radius and excess depth. So these are the two conditions based on which the optimization get performed. Right. Now we have the results for the solve. You just come back and have the results for the one that we just performed for 3D print. I can have again all kind of results in here. See wherein the displacement is maximum. So as inferred, here will be the maximum displacements. I can just slide the slider. Even see how it's behaving. This is vertical loading. Let's say I go for lateral loading. So this is how the part will behave. I can have callouts for different regions. So for example, if I just want the displacement at certain points, I can point them up. Even let's say I do not, okay, let's interpolate the results. So I can have this kind of results as well, wherein as the part is moving, the results will be changed as per the movement. Now come the main part that's called the compare results, right? So I just click on the compare results. We'll go ahead and compare the results that I already have. Right? It's just comparing now. In between, if you have any questions again, please feel free to ask. Right. So here are the results for all the runs that we have. So for all the runs, what was the original case? What was the maximum displacement in that very case? For the mass and for the different run that I have performed. Right. Here, maximum mass. Even I can enter my own kind of results. Let's say I just want factor of safety. What's the maximum minimum factor of safety in either of these case? What's the von Mises stress? Even for the callouts 1, 2, 3, we just want to compare the results. So we have all these results and we can now compare side by side. So as you might see, the below one has the minimum mass and we can see the results live over here. Even I can copy this and take it outside as well. Let's say I want to just present in a presentation or something of that sort. I'm freely allowed to do so as well. Right. Now, in here, we have completed this. We also have something called a report. I just click on the report and just give a name to it. We'll go ahead and create the report for some of the solves that you have done. And that will be handy for you. So it will automatically go ahead, as you might see in here, it's checking the component, taking the snapshot of the components with different kind of results. It's all automatic. I'm not doing anything. So it's automatically creating a report for me. Right? So I have the report. Now let me open that for you. right? So we have all the information about our model. Hide this. Right. So all the information of the different parts in the model, what kind of supports we have inserted, what are the loading conditions, and then what are the different displacements and all those kind of things. So this is a very cool feature if you are looking forward to present something and you just want to quickly run and create a report. This will be something which will become really handy, right? Now we'll open up for questions. So that's the majority of thing that I wanted to show today in here regarding the manufacturability, what different kind of results we have, and all the kind of controls that you have within Inspire. Now we'll open up for the questions. Now, any questions that you have, please feel free to ask. You can unmute yourself and ask your questions as well.
Yeah, and I just hope you don't mind me adding this, Ollie. I just wanted to add to this presentation to keep in mind everyone that Ollie has demonstrated a subset of the capabilities of the Inspire tools. So this is really just the design workflow. The idea behind this workflow is that if you had a CAD system, such as SolidWorks or Inventor, and you wanted to be able to come up with a very innovative concept that was much higher performing than more traditional, human design, you could use this to actually come up with initial concepts for ideas of high performing shapes using all the engineering inputs prior to actually committing to detailed design. There are other workflows in Inspire. Notice that there is have full manufacturing simulation that are available in Inspire, but we're just demonstrating the initial design optimization workflow just before I continue. So if you guys have any questions about Inspire workflow we showed today or any of the other Inspire tool sets, which we have not presented, the floor is open for those types of questions.
Yep.
And does anyone have any questions for Ollie?
Just maybe one. So the
Absolutely,
optimization,
absolutely.
yeah, the optimization that you just did on this, then you have different ways you can set that up. You could minimize mass based on, say, a deformation constraint, or or I think what you did there was maximize stiffness and tell it a percentage of the volume to keep. Is that how you did that? Now, if you had, can you do another type of analysis, say, if you had, I don't know, say a nonlinear buckling strength requirement or something like that for a part, could you put a buckling strength as a constraint and optimize geometry to meet something like that? Is it restricted to a linear static analysis type of scenario, or can it support nonlinear analysis?
Yeah. Thank you for that question.
Good question. That's a good question, George.
Yep.
Thank you.
Yeah. So
Or
as of
yeah.
now,
Rob, sorry.
Yeah.
So Rob, as of now, Inspire is limited to static structural kind of analysis, right?
Okay.
Now you have a heavier package that we just discussed that was called HyperWorks, right? So therein you have the capabilities to play around with nonlinear analysis as well. Right? Herein it will be mostly linear analysis that will be dealing up with.
Okay. Okay, thanks. Just
Yep. As we do not have any questions, if you have, please feel free to ask. I just want to show one more thing, a cool thing out here. So the thing is, once you're good with the design, you might come up with a question, right? What now? So you have the design, what to do next, right? So let's say you have this 3D printed design and you ask me, Ali, you tell me what to do next. How do we get it out from Inspire, right? This doesn't look cool as of now. This doesn't look, finished CAD model, and you might have difficulty creating this kind of a model in a CAD software. So within Spy interface, again, you have something called polynomial. So I just click over here. I can just click on fit polynomial. What it will do, it will go ahead and create a STL file for me. So wherein I can play around with the geometry using polynomials. I've just clicked it. It's just processing right now. So okay. So you might see it has already generated a STL file. Now you might see this surface is much more smoother than what we had. Right? It's generated a file which can be saved as a STL file. I can take it out and use it directly with my printer software. Right? Even if I just want to manipulate the CAD over here, I can just again go back a bit and create my own. So I just go into polynomials and now I can start wrapping around. So herein I have the flexibility of creating my own design and manipulating it as well. For example, I just click on here and I can just take things from here to here. It will create solid out of it. Just go to fit. Wrap. Select the surface and I can just create like this. So in this way, I can just move forward. And in the end, I can generate a geometry, something much more sleek and much more clean as well. Even in the end, if I just want to play around a bit, right, I have flexibility to play around as well. So for example, this is a polynomial created out of the same solid. And just go in here and let's say I just want to move this slightly outside or something of that sort when I want to rotate it. So you have those kind of flexibility as well. So in the end, you are getting a proper CAD model that can be exported as a STL file. Even again, I can just go ahead and analyze this component as well, which I've created using polynomial. You have hand-to-end solution. So I just had initial part. I went over and initially I just had something like this. If I just open the presentation. So initially we had something like this, right? We go ahead and try to do some kind of a defeaturing, wherein we were able to remove these holes so that the software is able to find a good amount of packaging space wherein it can play around and give us the proper optimized result, right? Then we got in and depending upon our manufacturing constraints, we created an ideal shape. We played around with different shapes. And once we finalize the shape, we check the performance of different shapes. And once we are good, we create using a polynomial, a geometry, which is good to take outside. We can use it for 3D printing, or we can give it to our design people as well. So we are good for manufacturing. So you have end-to-end workflow in here, where you just start from the very basic with the model that you already have, and you get the final results out of it in terms of the optimized result. Right. So now if you have any further questions, we'll be again taking your questions.
We do have a question from Clement.
Anyone else wanted to add something to the mix? I think we already answered this question, or no, hang on. Compared to CAD
The new
systems
one.
including. Okay, so the question we have is, compared to CAD systems included analysis generative capabilities, what are the most important capabilities your offers? So Ali, I think what they're asking is, there's obviously generative design offered in other systems such as CAD systems currently on the market. So I think what we're asking is, if we were to compare those CAD generative systems versus Inspire, what would be the additional benefits or features that Inspire would have that maybe could augment those generative workflows in existing CAD systems?
Thank you for that question, Ben. Thank you for rephrasing that question. So Clement, herein I just showed you a feature wherein we just have the structure, right? This Inspire is really powerful package in here. You get a lot of things, such as let's say you have a moving part and you want to optimize that for a moving part in here. So we have something called Inspire Motion, where you can just open a model with different moving parts and you just can optimize that, right? So if I just show you something in here real quick, I'll just go to motion. And something which is already optimized. All right. So herein you can see, so this was a solve wherein there was a motion, right? So you were having a kind of a motion in here. And based on this motion, software will automatically check what are the forces acting on the geometry. So initial geometry, if I just show you the initial geometry, this was the initial geometry. The software were able to find what all forces are there. And based on those forces, I can just go ahead and optimize. Not just that, I can, see what all forces we are getting on the motors and all. So if I just run the analyze in here, just real quick, we'll be preparing just click in here and see different kind of results out of it. So what's the torque that the motor will require to move this kind of a motion, right? You can see the speed, how it's varying and all those kind of things. So it's not just structures, you have motion capabilities as well, wherein there is a moving part, you do not know what kind of forces there are, the software will find it for you. Now, going a step further, you also have something called print 3D, right? Let's say you have optimized a part for 3D printing. Now you want to have a results out of it, see how the part will be printed. So we have something called 3D print, wherein you can get a result. So I'll just open that for you as well. Just give me a moment. Right. So for example, this is the part that we generated, and we want to see what kind of problems that can come while 3D printing. Will there be any kind of a deformation, any kind of those things? So I have those capabilities in here as well. Even I can see and manipulate and play around with different kind of supports, and I can get the file for those supports as well. Images, right? So you just do not have the structures. You have the motion capabilities within the Inspire. We have recently added the fluid capabilities as well. This is just an initial fluid analysis that you can do. So it's just one package wherein you can have different kind of things. Even post creating your design, let's say you have an end user to whom the aesthetic also matters, right? In that case, you want a rendered image out of this. So you have Inspire Render as well. So within one interface, you have different things to play around with, right? So you can just go ahead and render your component as well. So end to end, you can do the simulation, right? You just started with the geometry. You went with different kind of optimization. Once you got those optimization, if you have a motion solve, You can see what are the forces that's required by the motor so that you can, select the motor appropriately. Once you're good with that, you can print it and see what can be the problems, and you can, define different kind of supports and even different kind of orientation within the same software. So we just showed one aspect of Inspire because it will be a really lengthy and might be a bit complicated session. So we just kept it quite simple for structures for now. In future, we will definitely be having webinars on the topic wherein you can see these things as well. As you see, currently I've opened up the orientation toolbar in here, so I can see which angles it will take minimal amount of times, when I'll require maximum amount of support, all those kind of things. So it's just one package, but you get an ample amount of simulation capabilities, which might fulfill a lot of your needs that you have. That was a really big answer. So in short, Inspire can do simplification of geometry. It can design for manufacturability. It can simulate motion simulation as well. And even if you want rendered image out of it, it can do that as well. Sorry for the long answer, but that's what Inspire can do. I guess that answers your question.
Yeah, thanks, Ali. That was a comprehensive answer. It's difficult to answer. I mean, the big thing, I just wanted to add the comment on Ali, is the big thing that really, to me, has always distinguished Inspire from more simple or generative design is, one, the algorithms are extremely mature with the Altair line, because Altair's had their solver for topology since the 90s. So it's the most mature one with the most accurate results. And secondly, it has many additional features, including manufacturability, which a lot of other generative design packages do not do very well. So you can both do optimization for shape controls with manufacturability, along with all of the different types of simulation in the same environment. I hope that answers the question. So yeah.
Just I wish to add one more thing. So the solve that you get out of Inspire can also be taken to higher level software such as HyperMesh, Nastran if you want to take it. So you have the solve result that you can further go and analyze and get much more accurate results, right? So that's also one of the features of Inspire.
Okay. Thanks. I guess we're nearing the time for conclusion. Yeah. So just to notify everyone that we will be sending out the recording for this presentation. So if you want to take this presentation and share it with anyone else, along with the PowerPoint that was sent out as well, we will send that out. If you guys have any ideas about any Q&A sessions you would like in the future, please feel free to reach out to us with the marketing team, and we would absolutely love to be able to share the topics with other customers, so that way we get some feedback about running some new Q&A sessions. If you guys found this Q&A session useful, we'll definitely be running ones in the future, and we'd love to hear what topics or products you'd like us to cover. Okay.
Just to add on,
yeah.
We have just shared a form, just a feedback form. We'll just take 10 seconds for you to fill. We'll really appreciate if you can just find out time and just fill that form for us. It will really help us to have much more frequent sessions and much more informed session in the future.
Thanks very much, Ali. Thanks everyone for attending. Have a good day, and I hope you guys have a good rest of the week.
Take care, guys. Bye-bye from Team Futurescape.
Thank you.